Thanks everyone for showing up to Fundamentals of Building Science. We're going to talk about 5 whys for your house that you should think of as you're building now, in the future, or just wanting information for your current house. My name is Jason Baker-Brady. I'm the owner of Monticello Custom Homes and Remodeling. And this is...
My name is Brian. I'm Jason's superintendent. Jason has shown me, and we have grown to try to strive in very efficient homes and use these 5 things and incorporate them into houses as much as we possibly can. So I come from a construction background. My grandpa was a custom home builder. My aunt's an architect, so kind of just runs in our blood. I thought Jason was a fantastic match, and we both share the same passion.
And then just in general, building science, the definition of it is it's using other sciences to kind of just understand how applying other sciences to the construction for a systems approach to a house. And a lot of it to me is about comfort and durability more than about energy efficiency. Energy efficiency is a byproduct of a type house, using building science for it, but that's not the main approach. There's a lot of homes that are very efficient that are very uncomfortable, or that are very efficient but they are not that durable, because if you don't use a systems approach on it, it can fail faster than a house that's very poorly built. Because old houses, they've lasted a long time because they breathe. They get wet on the inside, it can dry out, but that's horrible for efficiency and comfort. You got cold walls, things like that. But one architect, he's always said it's building science, not rocket science. None of the stuff's that difficult to do. It's just a matter of breaking off the little pieces and figuring out what system, what group of those items you're going to use in your new house. And like I said a little bit earlier, it is more about comfort and durability than it is about efficiency. That is just a great byproduct of it. And then the 5 whys we will go over are why air sealing is important, why exterior insulation is important, why do I need a weather-resistant barrier, and even what that is, and then why I need a rain screen, again, what that is, and then why good HVAC install does matter. We'll just go ahead and get started with why air sealing is important. That helps get we get some of our notes there. Air sealing is basically just using construction methods to tighten up the house. We want to tighten it up on the outside. We don't want to go necessarily rely on just foam insulation that's back here to tighten the house. We want to use zip tape. We want to use whatever our outside material is, whether it's Hvac, this, fluid applied, any of that. We want to use that all. We want to air seal out here. We want to stop the air from getting in, because air in the house will bring in a lot of pollutants and things with it. And then to test the air sealing, we have to use a blower door. No jurisdiction in our area right now requires that. City of Springfield, I believe next year, is starting to require blower door test to test the air tightness of a home. It's been part of the code since I believe the 90s. The energy part is, but just now it's starting to be adopted in our area.
I follow with the blower door. It's a tool. We use it. Everyone's chasing numbers and get it as low as we can, but we try to use it as a tool to make us better and test our stuff to where we can strive to get better and better on every project.
Yeah, because we bought one last year so that we can test ours as we go through the process. Once we get insulation and everything in, we're going to go test ours. We can't rate ours, where once the code requires it, we can't do that part for our own, but we can make sure, we can test ours well before that to make sure that we can go back and touch up foam, touch up caulking, and do all that stuff as we are getting to that. So once we get to the test, it's just a formality more than anything. And then also the big one is that air does move from warm to cold. So as the year goes on and we are in the middle of the summer, which we're closing in on now, all that warm air from outside is wanting to get in your house. So any little cracks and crevices you have in your house, in your air barrier, they're going to find their way in. And then counter to that, during the winter, all that warm air that you've been paying money to heat inside the house is doing everything it can to get out. And this is an example of a remodel we had done last year, I think it was, that you can see they just put the sheathing right on the outside of the framing, and you can see the air or the gaps through there, but that's basically showing what's all making it into your house. That just, the insulation stopped it there, or stopped part of it there. Probably not all of it, probably more of that stuff made it into the house as well. So air sealing out on the outside, we can get to where insulation looks better like that, as opposed to that.
And I've seen plenty of projects, you pull it back and everyone, the first thought is mold. You know, I have mold on my insulation. You see the black on it, 99% of the time it's air just being filtered, pulled through, and it makes it so gross, and that's the filter into your house where your air you're breathing and your family lives in and everything like that. So it's just a telltale sign of, you know, how
leaky everything is.
Everything is.
There's a lot of different details that we could bore you for hours on details on air sealing. But some that we do are underneath our sill sealer. We actually run acoustical sealant below and above it. It's kind of overkill in that area, but it's one that it does help seal that connection that much more. As you can see, the concrete's very not real flat there, so that sill seal will compress, but it's not going to compress perfectly. And this is the only time we're going to be able to touch that area. We'll never be able to get back to it without a lot of other details later on, or a lot of stuff we have to do out here to try and stop that. So it's a very low cost little item to do to help seal up the house. Using the zip system, their tape is great at helping air seal that. Once it's put on and rolled like they show there, it will create an air barrier on the outside. And then even just foaming or caulking your windows. I prefer caulking because foam, when you don't get a real heavy bead, you don't meet the threshold where it does stop air. So you get to where it will still allow air to find through it. If you get a 1/4 inch bead or something like that at foam, it won't fully help there. But these ones definitely are all very important to try to get your house as tight as you possibly can.
Well, and I'll follow with Jason. I mean, it's a case of caulk, some tape that needs to be rolled. I mean, it's just these simple things that, you know, we can get our trades to do pretty easily. It's not a big deal just to run, you know, 3 beads of caulk around the foundation, and at that point, your structure is that much tighter, you know, in the end.
Yeah, and where you air seal, you also are bug sealing. If air can't get in it, water can't get in it, and bugs can't get in it. So people always seem to like that side of it there.
I look at if I get to sit on my couch and see the sun coming in, you just see that, you know, that dust running across it. And you go in these houses, and I mean, it's you don't have that dust and bugs, all of that.
The next one we're going to do, why exterior insulation is important. That is one back probably about 15 years ago. It went to the code. It's been opted out on around here again for most of the time, but basically that is, we've got one wall assembly here. We'll try to be careful to turn that. But this is part of the zip sheathing, and this one right here is the counterpart that does not have insulation. So this one just adds this exact one we use is the 1/2 inch insulation behind there. They've got up to, I believe, 2 inches of insulation behind the zip as well. The more you add out there, the better. But this just helps with overall insulation values. The stud is about R1 per inch, so this stud right here is really about R3.5. While this cavity, if you have a bad insulation in it, might be at, sorry, I'm gonna have a slide on that. But getting the actual R value stuff, just like I said, you have R3.5. If we have an R13 back there, the studs work out to be about 23 to 25% of the structure if you took them all and just slid them all together for the walls. So your actual R value on that does decrease significantly. That by the time you do the math on it, your wall really is, your R13 bat's really only about 10.7 in this area. So by us adding exterior insulation, by adding exterior insulation, we are doubling the R value of every stud. So we're going to build our R value in general up quite a bit. That will cut that down. I didn't do the math on that one, but we're going to get it back to about R13, R14, somewhere in there by just adding that ½ inch out there. And then one building scientist has always said that add as much exterior insulation as you can afford. It's the place it'll be the best bang for your buck out there. And then one little display here, thing we had done on this is we had basically built 2 coolers, one with the zip R, so this one's got the insulation on all sides of it, and then this one is just the normal zip stuff there. And we didn't fully test this one before, but this one's 42 inside, and this one's 60 degrees inside. Wow. They have the exact same ice in them, the exact same, everything inside of them is identical. But this one's keeping it quite a bit colder than that one, so during cooling months or heating months, you're going to keep more of that, whatever you're mechanically doing inside your house. Yeah, that's good. And then also with exterior insulation, it can help prevent condensation in the wall, because no matter what your wall looks like, you're going to have water vapor and water that does pass through the wall both ways. And once it does hit dew point, it will condensate. If you have an assembly like this, there's always a chance if it hits dew point back here on the back side of this OSB, it's going to form condensation back there, and you might get some of that mold Riley talked about. Or if it's on the back side of the drywall, you might get it there. This will, in our climate zone, will get you to where it's not going to happen now, because it can't reach that inside the wall cavity.
And to follow Jason, I mean, it's gonna start going into your house, and then it's gonna immediately start pulling. I mean, that's when you see rock falling. The sheathing is failing from the inside out, and it's just gonna progressively get worse and worse.
Then the next Y is going to be weather-resistant barriers. They are basically, there's several different types of weather-resistant barriers. There's self-adherent, basically they're big stickers you put on the house. I don't have an example of that one here, but it just goes over whatever substrate you use, whether it's plywood, OSB, the Dura-Rock type stuff, or glass rock. It can go over about any type of those. And then integrated, which the zip system is all an integrated, keep that one flipped around, but it is an integrated, it's part of the product, so it's one that it's applied at the factory, so whenever the installers install it, all they have to do is screw it on and then take the joints and it is done. And there's fluid applied, which basically are just painted on. And then there are mechanically applied, which is that Hvac type stuff you see. A lot of times you don't see it installed correctly. They're supposed to be installed with cap nails or cap staples, and then all the joints taped like this photo shows. Most of the time you'll see all the joints never taped, they're flapping in the wind, and then people are using slap staplers to put them on, so they really don't do what they're supposed to do. And all these, there's good uses for them in different applications. A lot depends on the style of the house. If you have a more Santa Fe style house that has no overhangs at all, getting into a fluid applied or a self-adherent is probably the best, because there's less chance of anything getting back there. And just what you're doing in the house can make a big difference on what type the best to use is. But, what else? Sorry. We'll get to that here in just a second. But the big point of a weather-resistant barrier is just keeping the building dry. We want to keep we want to control our water at this level, not this level. This is for bulk water control. This is for actually keeping water out of the house. We don't care if water gets behind this, we just don't want it behind this. And then that will, like we've mentioned several times on a lot of this stuff, is it will prevent rot, prevent bugs, prevent all that, because where there's rot on your OSB or anything like that, for that Hvac that's not installed correctly, you get rot, you'll get termites, you'll get all kinds of things. They want to go to that. And then, but all these, kind of also, all these are not the same. We've got one little display in the back of ours here. We went in, and this is just, this isn't Hvac, this is one of the more generic box store house wraps, but as you can see, this is just showing bulk water. This thing's full of water, but water does just work right through it. And most of the time at this level, we're dealing with water vapor more than true bulk water like this. It's not going to sit in there like this is showing, but if bulk water can get through, water vapor will have no problem getting through.
And this box, for example, this box down here is built out of zip and tape and liquid flash, exactly what we would put on a house.
Yeah, and that one's been holding water for, I had it in my garage for 2 days holding water with no leaks at all. So I'd much rather have something that'll hold water on the outside of my house as opposed to something that'll filter water for me.
And again, like I was talking earlier, even just as simple as it is to board and tape, it's not like Jason was saying, you know, all the flashing on the Hvac and cutting and cap nails and making sure you're flashing everything properly. If you miss one step, you've all of a sudden compromised your entire wall or window seal or, you know, other applications. So this is just, it makes this simple.
Well, and then with like the zip system, there's a lot of the way they, for now, there's a lot of integrated tapes and different things that they provide that we can use to flash our windowsills that all the way around there. It's the same tape. They've got stretch versions. They've got liquid flash that you can hit screw heads with if we want. Different things like that so that we can make sure we are tight so that everything does stay outside of the house. Moving along over to rain screens. And kind of what is a rain screen? A rain screen is pretty much anything that is behind your siding, sheathing or anything, whatever the decorative is, brick, vinyl, wood siding, stucco, anything. You need to get some air behind it, have a drainage plane behind it, because that same building scientist has always said if it cannot dry, it will die. That if we get water back here, because we will get water back here, there's no way around it, that if we can't let the water out, that's when rot starts. If we can let water out, it'll never start. I'm going to set that one piece of stuff underneath there. I'll show that. And like I mentioned earlier, water will get behind every siding, no matter what kind you have. Brick has a natural air barrier behind it because it's usually set about an inch from the house actually is where it is laid. So short of extra mortar falling down there to dam it up, the water will drive through it. Like if it gets wet on a rainy day and the sun comes out, that water will be pushed through the brick, and it'll get back here and it'll drop down and dry, no problems. But behind siding and all that, if water gets back there, it might make it down to the top of this and then slowly start pulling up, or where it's held tighter, it might dam up, or you might get some above the head flashing in a window, different things like that. You're just trapping moisture back there. But there's also a lot of different types of rain screen that you can use. You can get into the Keen product is what we use. It's basically a roll-out mat that you can, you just staple on. It'll go behind a lot of different types of material. We can put it behind our stone. We can put it behind our siding. About anything. We've got a stucco project coming up. We'll end up putting a thicker version of it behind all the stucco as well, so that as water gets back there, all those, and you don't run into those issues that stucco's had around here about a decade or 15 years ago, something like that, with all the stucco. But you can even get into as simple as 1x3, 1x4 backs on the wall and nail your siding to that, or you could do even, we've seen some people use the sill sealer like we talked about earlier, stapling that up on there and then put the siding on that. You don't need a lot of air, you just need a little bit of air just so that water can, once it makes it back there, it can get out. And we'll show you one on this one. Make sure we don't have that hole in here. Yeah. We'll kind of show, I've got just some dyed water here. And we'll kind of show you what this does do if we get a rain. Now, the water just drops straight down, won't get jammed up or create any issues in the wall now. And then also anything that does get wet, if the back side of this siding gets wet, there's air getting back there, so it will dry out as well.
And we're not talking here, are you gonna have rain or water get back behind there every rain? Probably not, but we've all been in storms that are monsoon, sideways, 40 mile an hour, and that's when it happens. So we have to let it get out. Like Jason said, we need air back behind there to dry it. It just needs to dry. If we let it dry, it will dry.
Yeah, and it'll help with the overall durability of the house when we get into, if you are painting your siding, it's one that if water gets back there, it will find its way out, but it'll drive through the siding, through the paint. And that's when after a time or two, it will start causing the paint to fail. So if you go in and you've got a painted wood siding, now all of a sudden it starts to fail a lot faster than if you get air behind it. The water drops, everything dries from all sides on your siding.
You look at like stone veneers, we've done several houses where we've done, a stone kind of wainscot around the bottom. We do rain screens where you see these older homes that have mortar cracks and stone falling off. And, it's because moisture's getting back behind there and it's drying and freezing and heating up, and it's just expanding everything to where it just causes it to fail. It's not able to dry behind it.
Mm-hmm. And we'll get into our last one then. Why a good HVAC install matters. Give us a second while we get this one set up for this side of it. Yeah, I'm going to turn that one around. Or kind of notice pointed to that wall, about like that. That way they can see me. And then pull that. Okay, this one's fine. But HVAC makes a huge difference. Once we went through the trouble of creating a nice airtight envelope, we controlled the water that's getting in there, we controlled all those things. HVAC, we have to mechanically comfort or make the area we're working in comfortable. So in a tight home, we typically have to get into an ERV or bring in fresh air mechanically. But the nice thing in doing that is that we are mechanically bringing it in, so we can bring it through a filter system as it's coming in. We're not using our insulation like that previous photo, bringing all our air in that way. We're actually mechanically bringing it in. We're going through a filter as it does come in the house. And then this slide and one other will kind of just show some good and bad. These are just all off the internet, but I've seen a lot very similar as well. A lot of flex duct, it's moving all over the place. No real rhyme or reason to how they're getting there. They're just kind of draping it however. And that greatly will affect the airflow and a lot of other things in there. This is a more ideal type system that you're getting into a lot of hard pipe. It can transfer the air from point A to point B a lot more efficiently. You'll get a lot better airflow out of it, and you don't create some other issues we kind of show you on this one. Whenever we do get to the areas where it does turn, like in that last one, uh, where things do this, we can start to create some issues in there. We'll just go into this. And this one right here is basically to, sorry. Oh, it is, sorry. We have got we won't go all the way to we've got a 300 CFM fan here going through our ductwork, out to our register, but most HVAC systems don't blow air at 300 CFM, so we've throttled this one back to about a little over 100 CFMs, which is where most air systems will move air. So that's what this one's showing now. Let's straighten that thing out. But hopefully you guys can see a little bit, or at least we can swing this around this way. This one as well. But once we go in there and now keep it straight. But as you can see, once we do this, we get a lot of good airflow out of there. You can feel that for a ways. We got a lot of these going up. But if we go in and we take, hold that one. We start getting ductwork like that first one.
Wow.
Yeah. You can start to see once how much that airflow kind of just dies once we get doing that. But if we get back to where we've got more like what a hard pipe would have on it,
That's amazing.
we start to get a lot of good airflow again. So that we're going to be able to heat and cool our house a lot better. And then also once we do get into these areas right here, the problem becomes if we've got that poor airflow as well, you're getting a lot of turbulence in these connections. So now they will be about 50 degrees on a cooling day, something like that, but we'll end up getting to where we can form condensation in there because a lot of duct work is in the attic that's 100 and some odd degrees, or in the crawl space that's a very moist area. So now that is going to start forming mold in there, forming mildew in there, and it's going to just start drooping even more. So a lot of issues with that, a lot of, I guess, good benefit in just making sure you have a lot of hard pipe or a lot of straight runs and everything.
And like kind of what Jason was saying about getting condensation, we want to control the air that's in the house. We spend so much time making it tight to where we can. So let's use what we can to control it. I mean, if we took all the time to make it to where it can hold all that air, let's control the air.
Cool. Well, that was the 5 whys that we had. Does anybody have any questions?
On the zip system, that's an OSB, I take it?
Yes. Yeah, it is an OSB behind
It's
it.
got some kind of a green vapor barrier, is that what that is?
Correct, yeah.
And then your ceiling with the black, just in 4x8 sheet panels, I take it?
Correct. They do make, I believe they make 4x9 and 4x10 sheets as well, but same idea. It is just the sheet good. It's OSB with a product on the outside, and there's other WeatherLogic from LP. They came out with one similar, and there's one other brand, I can't think of who it is, that makes one similar, that they do have it integrated.
So you, as a builder, you would be using the product with the insulation on the back of the OSB there?
Yeah.
Automatically?
That's what we do on
Special-
all, basically
Okay.
this one right here shows our, let's pull these out, I can spin this thing around. This is basically what our standard wall assembly looks like. We worked on it for a while, but if we go to a 2x4 wall, 2x6, obviously we just add to the insulation in here, but then we've got the zip R on the outside, whether we're using the 3.6 R1 here, the 1/2 inch, or we're going up to the 1 inch or any of those. But then we've gotten away from our walls. We don't use spray foam. We use a blown in fiberglass or cellulose, one of the two in there, because we can get a greater R value with this. Foam in 3.5 inches is about R13. This is about R15. And foam's a horrible sound dampener. So if you live by the highway, you're going to hear the highway. Whereas this is a lot better at killing the sound. So your house will feel a lot quieter. It'll be a lot more insulated because we've dealt with all the air out here. so we don't need the foam to stop the air in here.
I can back you up on the foam. I was told that it was actually going to be a sound dampener. It didn't do
No,
anything.
no. No, it will transfer the sound a lot.
So if you went with a 2x6 wall, of course, you're increasing the insulation at the same time, the white insulation.
Correct, yes.
How much does that cost, how much does that increase the cost of the home to do that?
It's not going to be a huge cost right now with lumber. It will feel like a huge cost, but but adding that, going to a 2x6 wall is not. I mean, it's hard to think of an exact percentage on it, but it's not going to be a huge cost at all on that because, and you're going to increase your R value here to about R18 is about where the bibs at 2x6 wall, and then if you go in and you add the 1/2 inch out there, you're pushing over R20 on your walls.
So it sounds like putting 2x6 is going to give me a stronger house.
Yeah.
And it's going to give me better insulation. And
Yeah,
not,
and you
not
can't
much
even-
additional cost, right?
Yeah, and you can even, to offset some of that, most of the houses in our area are framed 16 on center. But for years, there's always been a move to go to more advanced framing, which is 24 on center, floor joists, walls, trusses, things like that. You're getting wider, you have to stack everything a lot more, things like that. But then you start to cut out that 23 to 25% of the wall that is studs. You're taking 5% of that out. So even if you stuck with a 2x6 wall, but you went 24 on center, you can start to gain even more there.
So if I bring you my house plants, when can we get this underway?
Unfortunately for that, it's next year.
Okay. No, I'm serious.
No, right now we are booked till next year on new homes.
Hey, Jason,
Got several going now, and then several in the pipeline right now as well.
on Facebook Live, somebody's asking, what HVAC company is this? They would like to be able to refer them. So I just wanted to let you
Okay, yeah.
Field that
We're
one.
not an HVAC company. We're a builder, but we've just studied some of this. Went to Colorado a couple years pre-COVID now, I guess, to PC to Construction Instruction. That's a group that they just basically do a lot of hands-on teaching to this to builders, homeowners, a lot of things like that. And it's they did this whole thing here that was just thought was real interesting, getting to see the airflow difference in that. They are in a huge warehouse, so we could actually fire the air and be able to have people standing back there seeing where we could feel it. But we didn't have enough room here, and they wouldn't let me use my fog machine to try to help show it.
fire marshal wouldn't allow it. Yeah.
Anybody else have any other questions?
What was the temperature difference in those two boxes again?
About 20 degrees.
20 degrees.
Yeah.
Wow.
I don't know if it's gotten any different since we put these in here probably about 15 minutes before we got going. 43.9, 63.
Wow.
So quite the difference in there. And I put, once we built this last week, I had put that ice in there with a few drinks in, and it was 12 hours, the ice was still frozen. I think it was after 16, 17 hours, it started, it was, the ice in the ice had melted, but it hadn't, it was, everything in there was still cold. And after that, I went ahead and just took everything out. I didn't want to keep testing it, but that's what happens when you're a builder. You don't go buy expensive
A Monticello cooler. Yeah.
Yeah. But, cool, everybody, thank you for showing up, and we'll probably do it again next year, and probably find 5 other Ys or 5 other things, probably reuse some of these ones, but definitely new information as well.
Tell them to check out the Facebook so anybody that is not watching can watch it later.
Yeah, check out the Facebook Live. It's one you can watch it at any time. We've got a booth down in the middle of the big room there, so definitely feel free to stop by and talk while you're here at the show.
We post almost daily on Facebook, Instagram.
Oh, yeah. We post a lot on that, just showing a lot of things that how we build our houses. And then also, we'll mix in some of the pretty pictures of what it all looks like in the end. We don't want to be just all technical on it all. We want to kind of do a mix of it. But it's fun to share kind of how we do things that I think is a little different than a lot of other people do. So, thanks a lot.
Yeah, thanks.
Thank you.